So, why are we here? I want to take a second and just think about like what happened in the last 2 decades, right? The legacy that VMware has created, right? I was there. All of you seem to have been there probably. Just looking at the age distribution in the room, but like virtualization 20 plus years ago, right? On x86 platforms, has become a thing, and VMware has done a tremendous job, like furthering that technology, helping us as an industry, like do what we do today. But there has, come a stop to that recently, and this is not supposed to be like a vulture talk, right? We don't want to kick somebody who's already down, but we really want to just discuss with you, like, how can we help you in that journey, in decisions that you will have to make as existing customers, of virtual machine management platforms. So just to warm up a little bit and take my stress out since my speaker notes don't work, just by raise of hand, like who is dealing with legacy VMs day to day? Who is running mission critical loads in there? Please raise your hand. Good. Yeah. Check. Keep it up. Who is running vSphere? To do that. Even more hands, so thank you. That's good, right? So I think the decision that you're coming to, right, is like, what does this mean? What happened in our industry? Like, what's the business impact for you? What's the financial impact? What's the skills impact? And so that's the discussion we're seeking to have with you. But I want to frame this in the context of how SUSE looks at it, right? This is not a pitch about like a one-to-one VMware migration, right? This is not us. This is not SUSE. As you've heard in the keynote this morning, cloud native is what we do, and this is what we believe in. And then we have a couple of analyst quotes here, but this is really for us, the end state is cloud native. We believe, and I personally believe, in the paradigms that cloud native gives us in terms of how we architect applications, how we deploy them, how we develop them, right? And there's different, as I've learned in just conversations with some of you, in those last few days, different definitions and understandings and interpretations of what cloud native is. For me, it means freedom and choice to architect, for you to architect the application that you, serve to your customers in a way that fits your bill, right? It gives you the flexibility to accommodate on-prem, multi-cloud, hybrid cloud, you name it, and gives you that freedom. But there's a little bit of cost that comes with that freedom, right? There's complexity, perceived complexity that Kubernetes brings as the platform for cloud native. But who's better positioned, than Rancher to help you manage those complexities? By using Kubernetes, you will get the agility, the flexibility, the resiliency that modern applications require from you. And by putting virtualization next to Kubernetes, right, then you automatically inherit all those attributes. Real quick, double-clicking on another analyst paper, specifically CIO Guide to Broadcom's acquisition of VMware. Right, like I think at this point, a lot of companies that we talk to, they do an assessment of where are we, where's our cost, what does a change in pricing mean to us? Are there workloads that we've run traditionally on those platforms that maybe aren't mission critical? Can we move those already off to, maybe prevent some of those license fees that are being pushed onto us? Right, and so that's an exercise that's currently going on in a lot of people's heads, and I hope that resonates with some of you as well. As a consequence then, right, you have to assess what's next, what's the future. Again, for us, it's cloud native, but we understand that it's a journey to get there, and not everybody goes all the way to the end, right? It just sometimes doesn't make sense to do everything that you do today in a cloud native way. There's lots of reasons why you wouldn't go all the way there. But for you to assess that, right, a pilot, an understanding of how well your company, your business is equipped to actually walk that path, right, is critical. You will understand technical skills that are required, TCO, what are the migration costs, and so on and so forth. And finally, on obviously aligning your migration your transformation of the applications, with the goals of the business. And and I'm not going to do another hand-raising exercise, but I'd be hard-pressed to believe that cost reduction is not on, people's minds, for example, right? I think we always try to be more efficient, more resourceful in how we do things. And so I think in this conversation here, we have a good way to maybe share some thoughts of, how you can achieve those goals, with the help of SUSE. So why put Kubernetes and virtual machines next to each other? Right, that's kind of what we try to convey here. And one of the benefits that we see is you get to manage, both ways of deploying applications, containers, and VMs next to each other in one single pane of glass. Right? So instead of having multiple management systems, you get that single use case or single user interface to help manage that infrastructure, which then in turn will help simplify your operational costs. It will make your operations, not just the application, but the operations of the application more resilient if there's less surface for your IT teams, to run into issues. I've already touched base on the benefits of Kubernetes, resiliency and agility and scalability. Those are attributes that you inherit automatically if you manage virtual machines on top of Kubernetes. And with a lot of people that we talk, their development workflows also jive with what we call cloud-native development workflows. So in transitioning to Harvester, right, it is actually, it's not a migration off of where you are today or where you might be. A lot of them, all of you raised their hands for vSphere. Right? It's not a one-to-one migration. You don't just take something from here and move it over there. Eventually and over time, right, it is a transformation that you will have to undertake as you walk towards cloud native. And so a couple of benefits that we think are critical and that we've heard resonate, within us talking to analysts and customers and partners is licensing model. I mean, we've read all about it, how certain platforms, the licensing models exploded. There's thousands, if not tens of thousands of SKUs, lots of upsell opportunities where, people try to grab even further down into your pocket. If we look at Harvester pricing, it's an add-on to the Rancher Prime platform. So there's two SKUs or two SKU families, if you will, to deal with. And we're in the process of actually changing that model to utilization-based. So right now it's node-based, in the future will be utilization-based, a charging metric that you might be familiar with. I don't know that I need to talk much about the second bullet, right? Open source is just right here in our heart. We will not lock you in. There's no vendor login. Infrastructure is very sticky, and by going with SUSE, you have the benefit of all this code being available to you for the applications that you build on top of our products, and you have and will, right? That's a promise that we've made for 30 plus years now, and so, we will stick to that. And last but not least, just as another highlight, and I think we'll see this in future slides, there's some familiarity, right? So we'll be able to tap into existing muscle memory of what your admin teams, your IT teams might be used to, and then, when using Harvester. Because again, the primitives are very similar, right? Like a VM has certain objects that, it will consume in terms of CPU storage and memory, and so you'll see some good familiarity in there. Finally, just touching base on how it fits into our cloud-native portfolio, and I'm just giggling because that shade of gray is not showing. So think of it as 7 individual boxes, but this is the portfolio, right? Like if you look at SUSE's enterprise container management platform, right, we'll give you the OS to run your applications on with SUSE Linux Enterprise Micro, immutable safe OS, which you manage through Elemental. That's the bridge between the OS and actually Rancher, right? Elemental transfers those OS primitives into objects that we understand from a Kubernetes perspective. For those that have seen the keynote this morning, I'm super excited about our acquisition of Stack State. Something long in the running, a gap that we had for quite a while, and now we can give you full stack observability, on the SUSE cloud native stack or platform. New Vector, you've heard of this, of course, for security, and then distributed storage with Longhorn. Harvester obviously is the subject of this call. So this is not meant to be an architecture diagram, right? This is just a set of portfolio products that are making up the Rancher Prime portfolio. Good. With that, I'm going to hand over to Alejandro, talk a little bit more about what Harvester does.
Thanks. Let me see if this works. Does it?
I can move it forward.
All right, we're good. Okay. Okay. Let's go over Harvester. So who's had a Harvester introduction already? I've been in way more calls than that. Okay, so Harvester is a type 1 hypervisor, and it has a hyperconverged architecture, not in the sense of that every component has to be certified and it has to be this specific configuration and it has to be from this hardware vendor and this model, all that stuff. More in the sense of a software HCI. And then it is an environment where we run, it's a bare metal platform for Rancher workloads as well. So this is the architecture. We start with SUSE Linux Enterprise Micro, RK2, Longhorn, KubeVirt, which is how pretty much we talk with KVM through Kubernetes, Multus for the CNI of CNIs, so that we can enable VLAN management. Okay, and of course, managed with Rancher Prime. Some of the use cases where we see Harvester being very powerful is, first of all, using it as a bare metal environment for your containers. So you can just deploy containers on the bare metal cluster because it's RKE2. Then we have the ability to run traditional virtual machines because it uses KVM. It's using technology that we're familiar with for the last 10 or so years. If you think about all the components in the stack with the Harvester, most of them are mature, stable, and they've been here for a while. What's new? Longhorn is probably 5+ years. That's new. And the Harvester UI is in heavy development. Those are probably the only two components that are new. And then, so that we can run isolated container virtual machines through the Rancher lifecycle management of creation of clusters. Then we can deploy the Kubernetes clusters with a specific Kubernetes version that we need. Now, we mentioned 3 different use cases, but of course you can use all 3 use cases at the same time, which is running traditional virtual machines, bare metal containers, and virtualized Kubernetes clusters as provisioned by Rancher, consuming the CSI, the topology awareness that it provides us through the Harvester cloud provider interface, and all the automation that gives us as well. This brings us to our promise with Rancher of being able to manage clusters and the life cycle of those VMs across the cloud, data center, and the edge. Where do we, of course, want to run Harvester? Well, the edge and the data center. We have our cloud providers interfaces for the hyperscalers. If you haven't used or seen Harvester, this is the main dashboard. It comes with an embedded implementation of Prometheus and Grafana so that you can have access to metrics, dashboards, so that you can easily troubleshoot, understand what your resources are doing. The host management, there's clear visibility of what's deployed, the storage, the memory, the CPU. We can also set hosts to maintenance mode, so they would be drained out of virtual machines, and then we can perform any sort of maintenance to them. Pretty much all done through the underlying components. Then the intuitive VM administration. It's just creating a virtual machine. You're saying how many CPUs, memory, hard drives, which controller you want to use. You use SCSI, VirtIO, or pretty much anything you want to use. There's also a cloud-init implementation in Harvester, so you can perform all sort of automation tasks, creating, injecting SSH keys, installing packages, pretty much automating the deployment of your virtual machines. What are some of the things we can do with Harvester out of the box? We can stop, pause, restart, clone a virtual machine, take a snapshot, restart the snapshot. We have a graphical console, a serial console. Of course, we can delete the virtual machine. We can see the YAML configuration of that VM so that we can export it and use it as a template for Git deployment of other virtual machines. There's plenty of operations. Of course, live migration is also there. If you have a multiple node cluster, you can perform live migrations like you're familiar with your current virtualization platform. So what are some of the features that are out of the box with Harvester? There is Windows support. And when we talk about Windows support, it includes also VMDP, which is a virtual machine driver pack. Another thing that we've had for years that provides all the necessary drivers for Windows to natively work on our platform. Live migration, built-in high availability because of the built-in storage that we provide. The ability to clone machine, export machine, like we said, graphical interface, a serial port interface, the cloud-init implementation, an emulated TPM, GPU and vGPU support, a GPU by PCI pass-through, and the vGPU support with the NVIDIA ecosystem. How do we install Harvester? Either through a USB, an ISO. It's just like you would install any other hypervisor you've installed. You can, of course, because it has all the components in the ISO, you can easily deploy this in an air-gapped environment. And should you need to get any packages or anything like that, and you need to configure a proxy support, you just provide your proxy configuration. What's included in the storage part of things with the Harvester is the distributed block storage that is Longhorn that allows us to also create different tiers with storage classes. You can add pretty much labels to your, tag your hard disks, and then consume those respective hard disks as different storage classes. We can clone, edit, and manage your volumes. We can perform a backup and restore to NFS and S3. We can do hot plug of volumes. So if your workload is running, you need to add additional storage, you can do that. And we are heavily working on enabling the consumption of your current investment in storage. So that is something that we walk, crawl, run. We're in the process of starting to run. And some of these things are needed for us to do that so that you can consume some of your current storage investments. Of course, you can configure multiple networks. It's all VLAN networking. Configure your own SSO certificates. And one of the cool things is Harvester has a built-in load balancer. That is for traditional virtual machines, so you can just create a load balancer and point it to two web services that you have, if you haven't already containerized those. And it also allows us to create, when we create a Kubernetes cluster using Rancher, and we integrate with the cloud provider interface of Harvester, then we can expose services to the service type load balancer, and Harvester will handle that. Okay. Gaurav?
Thank you. So I'm going to try and help you migrate your virtual machine, say, of VMware or OpenStack as well, if you wish to. So Harvester ships with a few add-ons. So the add-ons are some capability that is packaged in but not enabled by default, because not everyone, for example, may need that capability in their environment or may not need it on each particular cluster. So one of those add-ons is the VM import add-on. The VM import add-on is an add-on that you can enable, and it allows you to migrate your VMs from, say, VMware or OpenStack-based source clusters. So to get started with it, it's pretty simple that you just have to define a migration YAML. So the idea is you tell us where is the source cluster. So there's like 3 main CRDs. So one CRD is the VMware source. There's an OpenStack source, and that basically defines the details of how to connect to your VMware cluster or your OpenStack cluster. And then you define the virtual machine migration YAML, which says, this is the source and this is the VM. And while you're migrating the VM, so for example, this is the new storage class for the importation of the VM. How do you map the network? So for example, if this is my VM network on, say, VMware, and this is the new VM network on Harvester, then the interfaces will be created and bound to the new, VLAN VM network on the Harvester side. So while performing the migration, we run quite a few checks to see, from the source VM as to, whether it's BIOS, EFI, do you have secure boot, TPM, all those sorts of settings are copied across. Information about the type of buses being used on your source VMs are also copied across, so we try and match the closest bus possible so that your VM can boot straight away without having to install any additional drivers. We do recommend that you do install the QEMU guest agent, because that is needed by KubeVirt internally to query and publish the IP address of your target the new virtual machine in Harvester. And we also make sure to copy across, say, the MAC addresses of your NICs from the source VM. So if, for example, your underlying layer 2 networks are the same, they're receiving broadcasts from the same DHCP server, we try and retain the same IP address as well. And when the migration kicks off, so a few steps are run whereby we power off the virtual machine and then export it, do some conversion of your disks, and load those disks into Harvester and create a VM object referencing the imported disks, and we just power on the virtual machine. So it's as simple as that. For more details, we have the details of the add-on as well, so you can refer to our doc site, which will provide you more information. So like the VMware source provider is getting updated a lot more frequently just because of the number of requests we seem to be getting from the community as well, where people trying to get off some of their VMware sprawl into Harvester. So if you run into issues, we are pretty responsive. Feel free to create a GitHub issue or talk to us on the Rancher users Slack, and we'd be happy to address those issues as well. So some announcements, for example, so unlike everything we do, everything is open source. Even our roadmap is open source. So if you go to github.com harvester and go to the wiki section on GitHub, you will find this exact roadmap there as well. Some things may move around based on, for example, conflicts of, resources, or what might, some things might get reprioritized, but we always make sure to keep, the wiki updated with our roadmap. So you can, please feel free to, go visit. If you feel there is something we can do to help, please feel free to create a GitHub issue, a feature request. Ollie and his team, will work to identify, that there seems to be a theme about something with the same sort of recurring sort of issues coming through as a feature request. So maybe we should look at it and prioritize it in subsequent releases. So we just released 1.3.1 last Friday. So the next release, major release, is going to be 1.4.0 followed by 1.5.0. So as you can see, there's quite a few features that we will be packaging in the future releases. The ones that I'm personally interested or I'm looking forward to, based on the number of conversations I've had with our customers and with the community, is the ability to boot from SAN. So for example, right now, Harvester can only be installed on local disks, but there's a recurring ask, as people try to get off other, virtualization platforms, and they wish to retain their infrastructure spending, or retain the infrastructure they've already spent on, so is to boot off SAN disks. And so that's something that I'm personally looking forward to. Then the next one is the Longhorn V2 engine, which we sort of have done some work in 1.3.1 to bring along. And with 1.4.0, we hope to get a tech preview enabled. So Longhorn V2 engine moves off Longhorn's original architecture of using iSCSI-based devices, block devices, to using NVMe over Fabric. So, based on whatever internal testing we've performed, it performs markedly faster than, say, Longhorn V1 engine. Then there is the cluster backups that we are looking forward to. And then obviously, some minor, improvements to, for example, maintenance mode. So as Al covered in the earlier slides, so you can perform maintenance operations on your hardware nodes. So for example, one of the add-ons is Cedar, which also allows you to do out-of-band operations on your underlying hardware. So basically, you can power cycle underlying hardware if you wish to perform maintenance, and So we're getting more feedback on what else people need. So watch this space. And then further down the line, we will be bringing 1.5, and again, there's quite a few features in there, but the two probably ones I'm looking forward to are the bare metal container workload support going GA, so then you can just use all of the Rancher capability to run container workloads along with VMs on your bare metal. And it's really useful based on what we've seen, with our customers and the open source community doing, that they need a place to stage their VMs while they figure out how to, translate or, port their apps from VMs to 100% containers. And then the second one would be, the VM DHCP controller. So again, it's something that we've been working on with one of our customers, whereby you do not wish to run a DHCP server on your layer 2 LANs, because, for example, you need a DHCP server on layer 2 LANs to offer DHCP. So we've worked on that as well, whereby the DHCP state is maintained within Harvester, so you can carve out a CIDR block and let Harvester do the DHCP management as well. So yeah, so this is what's come out in 1.3. So obviously, with 1.3, we focused on AI optimization with the NVIDIA vGPU support that got added via the PCI devices controller add-on. We've expanded the availability by allowing you to run Harvester now on ARM. There's again fleet management, which comes with the bare metal workload support now. And again, some additional optimizations for frequent power off, power on scenarios. Again, this is a sort of a long-running ask from some of our edge-based customers. And in the future, obviously, we look forward to bringing NFS and root disk placement support, so whereby you can use third-party CSIs for root disks in Harvester as well. And then dynamic cluster balancing. This is not the same as, say, DRS, but the idea is we should be able to rebalance the VMs by live migrating based on what the current state of the resource utilization is across all the nodes in your cluster. So yeah, so we have a few more sessions. So for example, that might help you on your journey. So Al and I will be at Demopalooza as well, so we'll try and demo the VM migration. I was hoping to demo it, but for some reason I can't connect to the network from here. I'm losing packets, but hopefully we'll have something for you tomorrow, and you can see the VM migration in action. So we plan to migrate a few Linux VMs, a few Windows VMs from VMware onto Harvester, and hopefully it'll add more context to what we've spoken about.
It's a surprise.
Too late.